Let's give the project amp a look over. Got our power transformer here. Monstrous output transformer. Controls our tone and volume, even though the schematic shows that there's 3 pots. That's kind of a mystery. It appears as though there has been some modifications. That used to be input 1 and there's input 2. Your typical Fender 5F2 lineup. Let's look underneath. So let's work our way underneath, but I wanted to point out first the sockets. You got your rectifier tube here, 6L6 output tube, speaker out 12AX7 socket, okay? And you can see the added bracket for the oversized output transformer. I'm not sure if it came that way originally. Alright, here's where it gets fun. Let's take a good look inside. So I'll just pan from one end to the other. We'll check out what's going on inside here. Homebrew turret board, actually facing the opposite way that I would normally see for a champ circuit. So the positive side of the filter caps are going this way instead of that way. No big deal. Got this actual like 18 gauge hookup wire going to the tube sockets, and these are those Chinese sockets I have a lot of problems with. So since I have to clean this up, I'll probably just go ahead and replace that socket. Got some broken shielded cables here. Solid copper bus network. I guess that's not such a bad deal. There's the back of the pots. You can see we got some more broken wires. Down here are the speaker leads. Just kind of hanging in the breeze. When I initially got it, this switch was laying in there, so I think somebody was trying to do a 4/8 ohm switching method. Got some black beauty caps in here for coupling. Those probably are going to have to go because they're probably leaking, right? I never use those. Here is the biasing, I believe, for the output tube. Your lamp, power switch, bottom of the power transformer. Right here is where the 5Y3 would go, and there's some diodes strapped on it. Not sure what that's about, but here's what we're going to do. I'm going to go ahead and isolate the power supply, bring it up on a variac, make sure that power transformer is good before we go any further. I removed those diodes off the rectifier tube socket. I'm just going to bring this up on my variac slowly. Just looking at the AC volts coming off the power transformer. You can see that the idiot light is coming on. So it looks like the power transformer is okay. Good sign. Next thing I'm going to do is clean up this wiring to the tube sockets, put it in a new preamp tube socket. Alright, well, I'm going to start by getting all this oversized 18 gauge wire out of here. Okay. Because I'm pretty much going to rewire everything. Use proper size wire, clean this thing up, make it look good inside. Well, here's a progress report. I removed that little boost switch from the front panel. I also have the new filament line going over to our 12AX7 socket. I've carved out all that excessive wire. I'm going to rewire this amp as stock. Then we'll see if we can get a signal through it. That's the best way to iron out all these weird problems. Alright, powering it up for the first time, and I decided I'd better check those black caps for leakage. Look at that one. About 2 volts on that guy. About 5 volts on that one. So yes, those black beauty caps are leaking, so they gotta come out before I test the amp. Okay, I've got the amp fully powered up. Here's my high voltage, 374. Here is the power to the 12AX7, there and there. Here is the cathode voltage on the 12AX7s. and that looks good too. So I believe we are ready to put a signal through it. This is voltage going to the cathode of the 6L6. Alright, no smoke, good sign. Let me get a scope out. We'll see if we can get a signal through it. Alright, it's powered up. I do not have an input to it at this time. I just want to look at the hum and noise level. So I'm going to crank up the volume. Let's look at the scope. You see we got a little bit of ripple here, but I'm at 50 millivolts per division. There's full volume. So the noise level looks great. Okay, let's get a signal in it and see what the sine wave looks like. Alright, using my trusty leader audio generator, going into input 2, I do not have input 1 wired right now. So we're going to bring up the volume and look at the scope. There she is. Looks pretty good. Vary the frequency a little bit. Yep. She looks alright. There she is, full bore. Appears to be working. Good sign. Let's get it on a speaker and see what it actually sounds like with that audio generator. Here we go, same test. Have an external speaker hooked up at this point. So there is a little bit of low level hum, but nothing that is offending. Okay, I'm going to bring up the volume now. You hear the white noise. So I'm kind of wondering about the gain. I have not checked these tubes yet. Alright, so she's quiet, but it may be lacking in gain, so let me check the tubes. Alright, discovered the gain problem. I actually had my audio generator on the wrong output. I was only putting in about 10 millivolts. So now we're putting in about a little over 100 millivolts. And we got a megaton of gain. Plenty of gain. So that solved that issue. Alright, next thing I need to do is get these input jacks wired. So this should have actually been input 1. So I'm just going to move this over here and wire in the second jack. Check this thing over, but man, are we close to having this project complete. So to eliminate that offensive hum, I did recap the amp with FNT caps. And now she's quiet as can be. So next thing, I'm going to get Tony over here. We're going to play it. And I bet you he'll like this little amp.
Hello, out in the shop doing a test for, this is kind of a unique 6L6 Class A type amp, which is a little unique in itself. It's on the powerful side for a Class A amp, and it sounds okay, sounds really pretty decent. When it came in here, it was a noise monster, but it wasn't really functioning properly at all. Terry's got it working quite well now, so